Alright, we want to do another energy conservation problem. And in this problem we want to say that we have some spring that we're going to compress. And we're going to compress some spring, let's say 10 centimeters. And when we compress that spring onto the spring, we're going to load a mass of 1 kilogram. And we're going to then launch the spring so that the block moves with some velocity after it's launched. So the question that we want to know is, what is our spring constant for this spring? So to look at this problem, we can use energy conservation because we know that the energy initial is going to be the kinetic energy plus the potential of gravity plus the potential of the spring. Where kinetic energy, we've said, is 1/2 mv final squared. Potential of gravity is mgh. And the potential for a spring is 1/2 k x squared. So for our initial energy, we know our block isn't moving, so we have no potential. We're on some level surface, so we have no gravitational. And so the energy of the spring is 1/2 k times our x squared, where x is 0.10 squared. Because we always use meters, and in this case we've compressed the spring 10 centimeters, which is 0.1 meter. So our initial energy is equal to 1/2. 0.1 is 0.01, and that's 0.01 K. So what's our final energy? Well, our final energy final, it's the same, it's kinetic plus potential plus the spring. Well, in this case, our final energy is going to be 1/2 of 1 times V final squared, which we don't know. We still don't have any gravitational because we didn't change height. And our spring now has gone back to its natural length, so it's at 0. So we see that our final energy is equal to 1/2 V final squared. So to find the K, we need to still make up a V final, and let's say that V final is equal to 5 meters per second. And that makes this 5 squared, which makes that 25 over 2 meters per joules. So when we set energy initial to energy final, we have 1/2 of 0.01 times our K equal to 25 over 2. We can cancel off the half, and so we have 0.01 times K is equal to 25. When we divide both sides by 0.01, we then get K is equal to 2,500 newtons per meter. So that would be our spring constant that we would have on that spring, that when we clicked it back, the 0.1 meter, 10 centimeters, and then launched the mass. To give that mass that initial velocity, the spring constant would have to be 2,500 newtons per meter.